Hello everyone, my name is Bastian Verhaelen. I'm a research associate at WBK Institute of Production Science at the Karlsruhe Institute of Technology in Germany. Today I will introduce you to a paper we wrote at WBK with the title Methodology for the Strategy-Oriented Distribution of Decision Autonomy in Global Production Networks. We wrote it together in a team of Dr. Benjamin Häfner and Professor Gisela, Lanza and me. In the current COVID crisis, we have a famous example of a Chinese company called Haier. They stated that at the end of February, they were already operating at full capacity again, thanks to their distinctive organizational design, which led to an increase in autonomy for production sites. With this high decision-making power for production sites, they have the chance to be ready to answer to changing market conditions in the COVID crisis. In general, global production networks are at the heart of value chains and also of production and supply chains. Nearly 80% of global trade in global production networks is relevant for this course of the paper. For example, if you have global production networks with 9 different sites, 37 product groups, 17 resources, and 317 process variants, you have a solution space of 10 to the power of 256 possible solutions. Compared to the number of atoms in a universe, it's quite big. In this complex environment, it's very meaningful to have a strategy that is oriented to the roots of the company. When we look at corporate crises in Germany, we see that 51 of them are due to result crisis. Only 32% are due to strategic crisis, but these strategic crises have the greatest lever for successfully transforming companies to a next level in order to be competitive. In this course, there is a question in where to set the course to implement strategic goals coming from high-level strategy to low-level plant or more operational level. The ideal distribution of decision autonomy is a structuring lever in global production networks. There is the question, what is the ideal distribution of decision autonomy in production networks? Is it either centralized in the headquarters or leading lead plants, or is it either decentralized at each production plant? We have threats coming from a non-ideal distribution of decision autonomy, like duplicated activities where, for example, decisions or simple activities are done at 2 different sites for the same purpose. Or we have high coordination efforts between sites and headquarters. We have a strategic long-term orientation that is endangered, but also slow decision-making processes and unused synergies between production plants. In the era of Industry 4.0 and digitalization, we have real-time capable systems which enable decisions on each plant with the usage of cross-site data in order to get an ideal decision. Also, we can use simple or sophisticated algorithms for big data in the production network to reach the global optimum for the whole company. Motivated from practice, we will show you 2 practical use cases. One is coming from Switzerland, where a site manager from a recently made company wants to be his own chef and wants to be decentrally responsible for decisions. But this company structure is highly centralized, and this leads to bad market conditions for this production site in Switzerland. Another one is the head of operations with a central function who wants to make lean structures for the production and operations functions in the company, and he has the questions for which structures or systems he needs to set up central things and what other decisions can be done by the company or by the production site itself. We differentiate between the market motive and the cost motive, which has the cost motive a more central orientation and the market motive a more decentral orientation. We have to conclude that the distribution of decision autonomy is not transparent from manufacturing companies. There is a need for an approach that supports companies in ensuring the appropriate distribution of decision autonomy in global production networks. Global production networks are, as stated by Professor Lanza in the CIRPe Annals keynote, can be elaborated in three different areas. We differentiate between strategy, footprint, and management. In this course, strategy, footprint, and management are relevant. In the strategy area, we focus on target system of companies and production sites, but also we focus on competence development and site works. The current state of the art is quite exhaustive in the area of subsidiary autonomy, but also in the area of autonomy and supply chain management. More recent works of, for example, Verhaelen and Häfner in a recent journal article from 2018 focus on the distribution of autonomy, decision autonomy in strategic decision areas. They also have a focus on influencing factors on this decision of distribution of decision autonomy, like the process type that is applied in the network and at the plant. We can conclude that there is a focus on centralization and autonomy in the literature. Furthermore, there are some basic relationships between influencing factors, decisions, and also strategy, but not a comprehensive one. Furthermore, there is no current methodology which defines an ideal autonomy, but also shows a way how to reach it. In order to answer this question, we developed a three-step approach with 4 different APs in working papers in order to solve the problem. In the first part, we describe strategy and target system, but also describe decisions and complexity. Furthermore, we use these description models to use them in impact models in order to get the impacts between decision and targets, but also between complexity and decisions. We use these models to select the ideal distribution on plant and network level for decision-making autonomy. On network level, we focus on network and production strategies coming from Professor Friedli from St. Gallen. He differentiates between market network strategy, competence and resources, local efficiency and global efficiency. We take these strategy types together in order to get a target system on network and production strategy level to get the overall target system for the company. On site level, we use different plant types that have a different orientation in order to fulfill their targets. These orientations are combined in order to get a target system to have a feeling what are the targets of different plant types. For example, low-cost plants have a high target on costs and also on market access, but less on flexibility. For example, responsive plant types, they don't have a special target on cost, but on flexibility, market access, and also on supply of the OEM, for example. On complexity level, we focus on external and internal complexity. Internal complexity is coming from external complexity from the customer side. So everything that the customer demands is transferred into internal complexity, according to PIC 2016, but also to Professor Wildemann from München. We use this in an exemplary morphological box of, for example, process complexity, where we have a qualitative comparison between different sites for each company that goes through the methodology. In order to have a feeling how complex different production sites are. This is all done for each company, for each production site, to have a comparable databases. For the decision autonomy, we focus on different decisions that we clustered into the score model of plan, source, make, deliver, and also on infrastructure. These decisions, like make or buy decisions, supplier selection, or for example, technology selection, can be allocated centrally in headquarters, for example, but also decentrally at each production plant worldwide. With this description, we have a feeling for each production site and the production network where each decision area is allocated. So we have a feeling for the degree of centralization and also the distribution of decisions in the production network. The general impact model between decisions and targets KPIs is done. Decisions come from the decision description model, target KPIs come from network and from plant level. For example, if you have a focus on delivery, it's good to have a decentrally distributed decision autonomy. But if you have a strong focus on production costs and on lean structures, it's good to have something centrally allocated in order to have synergies and also to have high usage of standards. This is done for each decision with each target KPI that is possible for production networks. Furthermore, we use complexity, the impact coming from complexity on decision. Olga and Häfner said that companies embed the autonomy to the production environment, which we translated into complexity in the global production networks, where we have databases coming from an international benchmarking study of 2020, which has a focus on complexity dimensions and their influence on different decisions, where to allocate them. So exemplary, right? You see the complexity in the dimension customer, for example, change of demand of customer, on the decision selection of processes at the site. There you can see with an increasing complexity and changing customer demands, strategic decisions on selection of processes are made more decentralized. We use this empirical inductive approach together with an analytical deductive approach in order to combine them, coming from theory and coming from surveys like benchmarking surveys as we did, to have a fully overview. With the help of this data, we can say, okay, for each production site, here state from production location Eastern Europe, we have the ideal distribution of decisions that are relevant for the production plant, but also for the production network, allocated either decentrally to the plant or to the production network. We can compare it from the orange one, which is the current status, for example, for a company, with the ideal degree of centralization for locations in Eastern Europe, for example, for the same company. So we can see the gap, the necessary adaptations of the autonomy. Here in this example, which is coming from an automotive industry, where we did some project and validation of the methodology, we see only relocations from network to site level. So focusing on market, focusing on decentrally oriented production plans, but also we see that, for example, the site role is defined centrally in each of the both cases. As a sum up, the motivation is that the strategic orientation of global production network leads to competitive advantage in history. Furthermore, the ideal distribution of decision autonomy to achieve a strategy is unclear. Therefore, the objective of this research is to see what is the ideal distribution of decision autonomy, and in order to reach that, we developed a methodology on how to determine the ideal decision autonomy for global production networks. We did this with a solution approach consisting of description models, impact models, and the ideal derivation of decision autonomy. The solution approach enables a strategy-oriented distribution of decision autonomy to determine the level of centralization of global production networks. There I'll use references. Thanks a lot for your attention. It was a pleasure, and bye-bye from Germany.